All right, now that you're all experts on the plant kingdom, I'm going to go back to kingdom fungi and we'll look at their life cycle. So you'll recall what you identify as a mushroom is actually just the reproductive structure of the organism. Sometimes it's called the fruiting body, but what you call the mushroom is the structure that produces spores. The actual fungus is the mycelium. This is the actual organism here. We have the real organism is the mycelium. Remember, all these little strands are called hyphae, and the organism lives primarily underground. So let's go ahead and look at the fungal life cycle and see what's very odd about it from our point of view. All right, here we have the mycelium, and the mycelium can either reproduce asexually or sexually. So we'll look at asexual reproduction first, and it's very straightforward. The mycelium, by mitosis, produces some spore-producing structure like the mushroom, and the mushroom produces spores like mitosis by mitosis, and they germinate back into the mycelium. Now, here is the odd thing, odd by our standards. If you excuse me, if you look at this key, everything listed here is haploid. So yes, typically the whole fungus organism, that whole mycelium is haploid. And the spore producing structures, i.e. the mushroom, all right, or the piece of mold, when you're looking at a mushroom, you are looking at a haploid organism. And again, it produces its haploid spores by mitosis. So there's also, the mycelium can also reproduce sexually, and this looks very, very odd by our standards. So let's say you have two fungi here that are different organisms. And we're going to draw the hyphae, because remember, it's the hyphae, it's the mycelium that's the actual organism. So let's say hyphae from two different fungi actually fuse. And remember that a lot of fungi are C-N-acidic. They have many nuclei without divisions. And remember, I've already told you that all these nuclei I'm drawing are haploid. They only have one chromosome of each type because that's typical of mycelium. They are haploid. All right, so for the sake of argument, I'm going to draw the nuclei of our other fungus a different color here. If I can get my, if I can be coordinated. Pointer options, pen, ink color, here we go. So let's say in this hyphae, its nuclei, yeah, coordination issue, there, we're going to represent blue nuclei. Now, what will happen when fungi sexually reproduce? So again, this is hyphae from one fungus, and this is a hyphae from another fungus. The fungi will fuse, their cytoplasm will fuse, and this is called plasmogamy, fusing the cytoplasms, but the nuclei will not fuse. They will just live together side by side. So you have the haploid nuclei from this hyphae and the haploid nuclei from this hyphae just living side by side. So these two different nuclei here, the red nucleus is haploid and the blue nucleus is haploid. And so since the two nuclei have not fused, this is called an N+N condition, or a heterokaryotic stage. This is very weird. We don't see this in animals. We don't see this in plants. Here, the cytoplasm is fused, but the two nuclei just refuse to fuse. They might be like this way for hours, days, weeks, years, even centuries. It's so very, very bizarre. I mean, you figure, why reproduce sexually if the nuclei aren't going to merge? Finally, they take their own sweet time. These two nuclei will merge, and we will get, when we have the fusion of the nucleus, this branches off, we finally have our zygote form, and as always, this zygote is diploid. But notice we didn't form the zygote by fusing a sperm with an egg. We fused two haploid nuclei from two different hyphae. So we're finally at the diploid stage. And then something, by our standards, very weird happens. That zygote immediately undergoes meiosis and produces, I don't know why they didn't just put 4 here, 4 haploid spores. All right, so we're immediately back to the haploid stage, and each spore germinates into a new mycelium, a new fungal organisms. So you can see why this is sexual reproduction, because we combined two genetically different nuclei from two different genetically different fungi, And after they hung out together for a long time in this weird heterokaryon, you can see the definition here, unfused nuclei from two different parents. All right, after the nuclei hang out here for a long, long time, they finally fuse, you get a diploid zygote, and it immediately undergoes meiosis. So in some sense, a fungus life cycle is the complete opposite of a human because we are diploid organisms and we only have the only haploid stage in our life cycle are the gametes, the sperm and the egg. But as soon as we produce them, they immediately fuse to form the diploid zygote. So the haploid stage in humans is only one cell long, which are the gametes. It's the opposite in fungus. The only diploid stage of a fungal life cycle is the zygote, and it's only one cell, and it is very short time because it immediately divides by meiosis and produces 4 haploid spores. So again, from our point of view, a fungal life cycle is very strange and weird. All right, here's some questions I'll let you read to think about and consider before you take your quiz next weekend on plants and fungi. So, one note I have here, fungi can reproduce asexually by releasing haploid spores produced by mitosis. Hopefully you understand every word of that sentence. So here's something I want you to think about. What part of the fungal life cycles is similar to alternation of generation found in plants? But why is it also not truly alternation of generation? I'm going to encourage you to comment on that in the comment box, and this time I'm working a little differently. The first people to give me legitimate answers, you're going to get extra credit on your quiz next weekend. And then I think I've already told you the answer, but hopefully you know the answer to this review question. What aspect of the fungal life cycle is non-analogous, meaning it has absolutely no counterpart to the plant and animal life cycles? Hint, hint, N+N. All right. Couple other little things about fungi you should know for your quiz next weekend. You should know some benefits specifically to humans. And one benefit of fungi to humans is they provide us with food. I personally love blue cheese dressing and blue cheese as a mold. It's very tasty to me, and also other types of fungus. Mushrooms we like to put on our pizza. Morels are wonderful fungi that are very highly prized, so you should know that. And one other thing you should review, two other things. Another benefit to humans, again, this is the mold in the mushrooms, but the yeast, remember, yeast are unicellular fungi. So even though we tend to say, oh, kingdom fungi is made up of multicellular eukaryotes, yeast are one-celled fungi. That's what I'm attempting to draw here with their cell wall made out of chitin. Yeast, when they eat sugar, they break it down, and the byproducts are ethyl alcohol, which is the active ingredient of any alcoholic beverage. And when they eat sugar, in addition to producing the ethyl alcohol, they also excrete carbon dioxide. So the brewing industry obviously benefits from the yeast producing ethyl alcohol, and the baking industry benefits because yeast produce carbon dioxide. When you put yeast in the bread, the carbon dioxide bubbles causes the bread to rise. It also, they produce both simultaneously. So the yeast in your bread that are producing carbon dioxide, they also produce alcohol, but it evaporates while the bread is baking. So sorry if you don't get, to get drunk by eating some bread. But it sure smells good while it's baking. So know that for your next quiz. And one other thing, many fungi are pathogenic, just like the other microbes we studied. So in humans, I want you to be able to name 2 fungal diseases that make humans sick, and also 2 fungal diseases that infect plants. These have been very, 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 very important ecologically. They're not good, but ecologically, fungal diseases which affect plants have been very, very important, especially in the natural history of the United States. So that's all I have to say about fungus for right now, and I hope it's been a little bit fun, and I'll see you in the next module. Bye.